This is part 2 of today's lesson, and here we are going to end up having denominators that are not the same. And so in this case, looking at the first one, I see x plus 1 and I see an x minus 1. Now you just can't multiply by a negative 1 because it would change the sign of the x. But the x is already the right sign. They're both positive. It's just the 1 that's different. So these are totally different numbers. So we're going to end up having to multiply by the other's denominator. But before we get to that, let's go ahead and change this to an addition problem. I think you'll make less errors if you do that. And then from there, I'm going to multiply this one by an x plus 1 over x plus 1. And this one by an x minus 1 over x minus 1. So another problem people have is that they don't distribute. You've got to distribute the 3 over both of those numbers in that expression. Negative 2 over both of these numbers. So let's rewrite what we've got. Now you can write this as one fraction now because we have the same denominator. So I have 3x minus 3. That's what I get when I distribute the 3 over that difference there. Now negative 2 times x is negative 2x and a negative 2. And so this is all over that same denominator of x minus 1, x plus 1. I like to do that, leave it in the factored form, because you might end up reducing. Once in a while it ends up happening. And so we'll go ahead and collect some like terms. So I get this 3x and the negative 2x. That makes just x. Over here I have a negative 3 and a negative 2. I have to add those two, and I end up with a negative 5. Down below I have the x minus 1 times by the x plus 1. And that's our answer. Now you could end up multiplying out that denominator and getting x minus 5 over x squared minus 1. The outside and inside terms cancel out. Either way would be a sufficient answer for me. So same sort of thing on this one. We have x minus 2, x plus 2. They're not the same. You got to multiply by the other's denominator. Change it to an addition problem first, and then we'll do the work. So x minus 2 over x minus 2 is what we're multiplying the right side by. X plus 2 over x plus 2 is what we multiply the left side by. So distribute and see what you get. You got a 5x squared plus 10x. On this side, distribute and see what you get. You got negative 3x plus 6. And then down below, just leave it in that factored form. So we got an x plus 2 and an x minus 2. And so we go ahead and combine any like terms we can. So I see that the x's will combine. We've got 10x here, negative 3x here. So now we've got 5x squared plus 7x, and it's a plus 6. And so the whole idea is to see if there's any canceling that can occur. And so your factors that would cancel would be an x plus 2 or an x minus 2. So in order to check to see if this reduces, just try x plus 2 or x minus 2 is one of the factors. I can't use x minus 2 because they have to be the same sign. They have to add and make a positive. So the only way it would end up canceling is if I could get this to factor with an x plus 2. And so it would have to be 5x, and it would have to be 3. And so all you do is you check those outside-inside terms to see if they make 7x. But they don't. They make 13. So you know that does not end up factoring. And so this would be your answer right here. Now you could end up multiplying the denominator, or just leave it in that form for me. Same thing over here. No common factors, no reducing. So we're just going to multiply this by 3x over 3x. This side, x plus 4 over an x plus 4. So again, the key is distribute first. And so we've got an 8x plus 32. Over on this side, distribute that. We've got a positive 18x. Down below, we've got this 3x multiplied by an x plus 4. So we go ahead and collect some like terms there. So we see that we'd have 8x and the 18x makes a 26x plus 32. Now this is all over 3x times by x plus 4. Now we could end up taking out a 2. 2 goes into these two numbers. However, there's no 2 down here. And when we do the division, we don't get an x plus 4. We get a 13x plus 16. So there's no reason to end up doing the factoring because it doesn't end up reducing this any further. So we can just leave it in that form. So we've got another problem to practice similar to that. Here again, change it to an addition problem. And so when I do that, let's see here, I ended up not changing this sign here, or maybe this was an addition problem to start with, so we'll just leave that one the way it is. Change this one to an addition problem, and this one to negative, and then multiply by the other's denominator. See, there's no canceling that can occur except for this 2 here and this x. So let's go ahead and do that real quick. Let's reduce this down to 1 over x. If I could reduce up and down, I'll go ahead and do that some of the time. Not all the time, but in this case I'll do it this time. So I've got 1 over x here. I cannot cancel these x's, so I can just reduce or multiply this by x over x and this one by an x plus 4 over an x plus 4. So I go ahead and multiply, and 1 times the number's not going to change anything, so it's just an x plus 4. Over on this side I've got the negative x squared. Down below I've got an x times by x plus 4. So let's go ahead and rearrange this real quick. And I've got a negative x squared plus x and a plus 4. And if I were to reverse this, get rid of this negative sign here, I would end up with this as the factored form. Negative 1 times by x squared minus x, and then a minus 4. Now, I could try to factor the trinomial up here, but it doesn't factor because I can't find numbers that multiply to make negative 4 but subtract to make negative 1. See, 4 and 1 multiply to make 4, but those subtract to make 3, and then 2 and 2 subtract to make 0. So can't do any canceling here, so you could have the answer in either of these two forms is fine. So this next one, we're going to want to factor this trinomial here. Whenever you see there were no common factors between the denominators of these fractions, but there could be common factors here. So let's go ahead and factor this. Y plus, or actually minus 3 and a minus 1 is what we get. Here we have a 3 on the outside, and we got y minus 3. Now, instead of doing reducing, you could end up canceling out the y minus 1s here, and that might be easier in this case. So notice how I look at this numerator, and I do see a common factor here. Sometimes I'll take it out and reduce from this point, but sometimes I won't. In this case I will, because it makes the problem easier. So go ahead and take out that common factor of y. And so now I can cancel out the y minus 1s. So all I need to multiply this side by is a 3. And so that's what I'm going to end up doing. So before I get to that, let's go ahead and change this to an addition problem real quick so I don't make some errors. So there it is, and let's multiply this by 3 over 3. So just 3 times by y minus 3 leaves me at the same denominator. Distribute this, we got 3y plus negative 2y plus 2. Down below we got the 3 times by y minus 3. So we're able to collect some like terms on top. We're left to go y plus 2 over 3 times by y minus 3. And I'll just leave the answer like that. You could distribute the 3 over that subtraction in the denominator, but you could leave it in the factored form as well. So here's another one. Let's go ahead and do the same sort of thing. So with the denominators that you see common factors for, take out those common factors to see if there is a common factor between these binomials, or this binomial and this constant. And so I have an m minus 2 and a m minus 2 for this one. Here I have an m minus 2. Now here I can't do any canceling. See, m squared is not going to cancel anything out here. 3m is not going to cancel anything out here. So let's go ahead and change this to an addition problem. And this side needs a 4. That's what it's missing. This side needs an m minus 2. That's what it's missing. You see, now the denominators are the same. 2m minus 2's and 1 4. And so we go ahead and now distribute to see what's left over. We got a 3m squared minus 6m. Up here we've got negative m squared times by 4 makes a negative 4m squared. And so down below we've got the 4 times by an m minus 2 and an m plus 2. Leave it in the factored form because you might end up doing some reducing afterwards. So go ahead and collect some like terms here. We got the 3m squared and the negative 4m squared. That makes a negative m squared minus 6m. And down below we've got a 4, and that's being multiplied by an m minus 2 and an m plus 2. Now you could end up factoring out a common factor of m, but if you do that, you're left with an m minus 6, or negative m minus 6. And there's no m minus 6 or m plus 6 or anything like that. And the m would not cancel out down below either. So we're just going to leave the answer just like this, and that would be our simplified form. So those are some of the problems similar problems to what you'll see on tonight's homework. Good luck.